Hello, we are going to start Chapter 8 now, and Unit 8 is all about polynomials, and for a lot of you, polynomials might be a word that you are unfamiliar with. Maybe you've never heard that word before. So we are going to start by doing a little graphic organizer to help you understand more about what polynomials are. A polynomial is a monomial or the sum of monomials. Now, that might not help you understand because that might have just introduced another word that you don't know, and that is the word monomial. But don't worry, we will define that. So just write this down. Make sure you know you can pause the video if you need to catch up and get that down. Now, before we move on, notice that it says that a polynomial is a monomial or the sum of monomials. Sum means plus, but because adding and subtracting are opposites, and you can always change subtracting into adding the opposite, then you could also see subtraction signs. So that's why I wrote in here that it could also be a difference of monomials, and I'll put a little subtraction sign back there. So you could see things being added, or you could see things being subtracted, and those are polynomials. Let's move on to what a monomial is, so you understand a little bit more. You have actually seen polynomials and monomials your entire life. You just probably didn't know the words polynomial and monomial. There are three different things that a monomial could be. First of all, if we just have a number, we could call that a monomial. So if I just say the number 12, that's a monomial. Also, a monomial could just be a variable, and you know that a variable is a letter that's standing for a number, it's representing a number. So if I just have the variable x, that is a monomial. The third definition of a monomial is that a monomial could be a product of a number and one or more variables. So that's why I put it's the product of a number and a variable or variables. So that one's a little bit longer. Product means multiply. So when I multiply, like 5 and x, and I just say 5x, that's a monomial. So now we're going to write some examples. We'll do that below this bubble. Some examples of monomials, I've actually mentioned some. We could have just a number, like the number 12, as I said before. That's a monomial. Or you could have a variable, so pick your favorite letter. I'll put an x down. That's a monomial. Or a product of them. So if I decide to multiply 12 and x, and I just put 12x, that is also a monomial. So there you have three examples of monomials. Now we could make them longer. Maybe I go crazy and I say something like 3ABC. That is a monomial right there. It's a product of a number, 3, and 3 variables, a, b, and c. Let's see, another one could be like negative 7xy. That's the product of a number and 2 variables. So negative 7xy, we would say that that is a monomial. You could also have fractions as long as the number is a fraction. You can't put your variable on the bottom of a fraction because then you're dividing by your variable, and you can't do that. But you could have like 1/2. Let's put that right here. You could have like 1/2. I don't know. Pick some letters. P and then Q. 1/2 PQ. That is a monomial. It's the product of a number and a couple variables. So that is monomials. Let's move on. There are two other types of polynomials. When we start adding monomials together, notice if you go back to the definition of polynomial, It says a polynomial is a monomial or the sum of monomials, and we said it could also be a difference. So when you start adding or subtracting monomials together, then you are making polynomials, and we have special names for some of those. First, we have binomials, and you might know the prefix bi means two. So if you are adding two monomials together, then we call that a binomial. So some examples of this would be, let's just take a number and a letter, and if we just say like, oh, x plus 5. That's the sum of two monomials, x and 5, so that we just created a binomial. Let's see, if we have like xy, that's a monomial, and then we go minus 5a, because that's another binomial. So xy minus 5a is a binomial. It's a difference, which remember that's okay, it's a difference of two monomials. The ones you're going to see are most like our first ones, like x plus 5. We could say like, you could switch and start with a number. Let's go 8 plus y. That's another example of a binomial. Let's just do a couple more. You could have just two letters, y minus z. That is a binomial. Or, you know, a plus b, something like that. So when you have two monomials and you have an addition or a subtraction sign in between them, then you have a binomial. A lot of times, you know, earlier in the year, you've probably heard us talk about combining like terms. We will do that more in this unit. And so just know that we call each item in a binomial is called a term. So like when I just wrote a plus b, we say that has two terms. A is a term and b is a term. So I know you've heard the word term before. Now remember, you can't combine a and b because they're not the same letters. You can't add them together. You just have to write a plus b and leave it like that. Okay, and then in our third circle, let's see, we're kind of getting bigger. We started with monomials, which had one item. Then we had binomials, which have two items separated by addition and subtraction signs. So if we get a little bit bigger, then we are creating something called a trinomial. And as you can guess, a trinomial is the sum of three monomials. And again, it could have addition signs or it could have some subtraction signs as well. So an example of a trinomial is, let's say, x squared plus x plus 5. That is a trinomial. There are three terms, 1, 2, and 3, and they are separated by addition signs, and like I said, they could also be subtraction signs. Another example, we can throw more numbers in here and say that we have something like 3a plus 2b minus 10. That is also a trinomial. There are three monomials, and they are being added or subtracted together. And again, remember, you can't actually simplify that expression and get anything because this first term is an a, and then the second one has a b, and the last term doesn't have a letter at all, so you can't actually combine them. Goes back to combining like terms. One other example of a trinomial, we could start with a number 2 plus 3x, and then maybe minus 5y. Okay? So there you have your basic definitions of monomials, binomials, and trinomials. After trinomial, we could make longer polynomials. We just don't have special names for them. So if you ever have one that has 4 or more terms in it, we just call it a polynomial. We don't have a special name for it. Okay, so now that you have the basic definitions of the different types of polynomials, we're going to have some practice with identifying polynomials. So this first example is a table here, and we have to do two things. We have to state whether each expression is a polynomial or not, and if it is a polynomial, we have to identify it as either a monomial binomial, or trinomial. So let's look at the first one. We have 2x minus 3yz. Let's see, 2x, that is a monomial, and 3yz is also a monomial. So this is technically a difference of two monomials, and we talked about how that's okay. It could be a sum or it could be a difference, because subtracting is the same as just like adding the opposite, so then it would be a sum. So yes, this is a polynomial. So in the next column, we want to put yes, it is a polynomial. And since it has two terms, then that means that it is a binomial. So in the third column, we write that it is a binomial. Okay. Now let's look at the next one. Looking at it at first, you might think that it's kind of like the first one. It has two terms, and you see a plus sign there. So you might think, oh yeah, it's a polynomial and it's a binomial. But there's something tricky about this one. And that is if you look at the exponents. The 8n to the third is fine. There's nothing wrong with that. We can have as high of exponents as we want. It's the other exponent, this -2, that is really bothersome. We haven't practiced it very much this year yet, and we will in this unit, but with a negative exponent, what that really means is, that really means dividing. So 5n to the -2 really becomes 5, the 5 stays on top, but the negative exponent means make a fraction. And it means to put the n on the bottom and then change the negative exponent into a positive. So the 5n to the -2 becomes this fraction, and as I mentioned before, you're not allowed to have variables on the bottom of a fraction and still have it be a polynomial. I mean, you're allowed to do it, it's just not a polynomial anymore. So because of that, that makes this a no. It's not a polynomial, so then it's not either a monomial, binomial, or trinomial. But if you need to write yourself a little note here, maybe write down that you cannot, let's say we cannot divide by a variable. So if you ever see a fraction with a variable on the bottom here, that means it's not a polynomial. And a negative exponent makes that happen as well. Okay, the next expression is just the number -8. If we go back up to our notes, you see that underneath monomial, the first little definition there is that a monomial could just be a number. And we had examples of numbers that were monomials. So that means that this is a polynomial. So this is a yes. And there is just one thing to it, one number. So it is a monomial. Okay, last one. This could look a little bit familiar. All plus signs, that's a good thing. No dividing, another good thing. We have 4a squared, 5a, another a, and then the number 9. It's definitely a polynomial. So yes, because it is the sum of monomials there. And then you might think that, well, there's 4 things, and so it's maybe you're confused about what to write in the last box. Well, actually, go back to simplifying expressions. Look at those two middle terms, 5a and a. Those can be added together to make 6a. So this long polynomial can be simplified into 4a squared plus 6a plus 9. And so that has 3 terms, and so that makes it a trinomial. So if you can simplify them, you do, to classify them. But just remember to be careful. You don't want to add them together if you're not allowed to. Like, remember they have to have the same letters and the same exponents in order to be added or subtracted together, in order to be combined. So there we have a table there with some examples on classifying our polynomials. The next thing that we're going to do in this lesson is we are going to look at shapes, and we are going to write polynomials to represent areas of shaded regions. So in this example, we have a big rectangle, but it's not all shaded. There's a triangle that has been basically just cut out. So the area of the shaded region would be the area of the rectangle minus the area of the triangle. So we have a little bit of geometry review to do this. Now, there are formulas that you will need to be able to reference. And if you look at the back of your checklist, there is a table of important formulas that you might need to know for this unit. So the area of a rectangle, the formula for that is that it's the length of the rectangle times the width of the rectangle. And so to find the area of the shaded region in this picture, we want to take that area, length times width, minus the area of the triangle, and the area of this triangle, or the formula for the area of the triangle is 1/2 times the base of the triangle times the height of the triangle. So in that step right there, I just used the formulas. So if you're confused about, well, how'd you get all that stuff? That was just using formulas. I'm just setting the problem up. Now I'm going to apply those formulas to the picture that we see. Starting with the rectangle, what is the length of the rectangle? Well, the length of the rectangle is how long it is. And I see in the picture that there's a B along the bottom of the rectangle. So that is a B. So the length of the rectangle is B. The width of this rectangle is the 2h. So we're going to take B times 2h, and that is how you would find the area of the rectangle. But the shaded region is that minus the triangle. So I'm going to go on to my next step. I have my minus sign. And we look at the triangle in the picture. And the formula for the area of a triangle starts with 1/2, so I'm going to start with that. And it just so happens that the triangle in the picture has a base that is B, and the height of the triangle is h. So that is pretty much the same as the formula for the area of a triangle because of the letters that they used. So again, I just got this right here. I just got that from looking up at the picture. The B is the base of the triangle, and the h is the height of the triangle. So now we want to simplify this expression if we can. You don't want to force it, but sometimes you can, sometimes you can't. So looking at the first part, you have B times 2h. Well, a better way to write that is to bring the number out front. And since that's all multiplying, you can do that. You can move them around. And then just write the letters in alphabetical order. So 2BH. That's just how we do it in math. And then the second part, after the minus sign, that's as simplified as it can get right now, 1/2 BH. And then we can look at this subtraction problem. Since these terms, we have a binomial right here.
Tim Entrican, please call extension.
Sorry about that. Since we have a binomial here, and they have the same exact letters, and also the same exponents, you don't see any exponents, but since they have the same letters here, that means we can actually combine them. So this is 2BH minus 1/2 BH. Well, 2 minus 1/2 is 1/2. So we write that it's 1/2 BH. But then I don't want you to forget that with area, there's a label of units squared. This didn't say like feet or inches or meters or anything like that. If it did, we would use those words, and we would just put a little squared after it. But since it doesn't say, we just put the word units and then an exponent of a 2, units squared. And that's just the label for area. It's units squared. So the area of the shaded region is 1.5 times b times h, so 1.5 bh units squared. All right, the last part of this lesson is that we need to make sure that we are writing our polynomials in order so that we are all consistent with how we do that. In math, the most common way to do this is to write them in descending order, which means that we start with the highest power, which is like an exponent. A power is an exponent. So start with the highest exponent and end with the lowest power. So descending means you start with the biggest and you end with the smallest. I think you'll like this part. You just have to be careful. So the directions here say arrange the terms of each, should be polynomial, of each polynomial, so that the powers of x are in descending order. Now, it is important that you know that we're talking about the powers of x, especially in example number 4, when you have 2 or 3 different variables. You might think, well, what variable am I supposed to go by? And we usually just go by the powers of the x letter, the variable x. So in the first example, I guess here we also have 2 variables. So the first term, 8, doesn't have an x at all. So its power of x would be 0, so it'll actually be the lowest. But for our second term, 7x squared, here you have a 2. The third term is a 12xy to the third power. The 3 doesn't matter because that's with the y. So remember, we're looking at the x. If you don't see a power or an exponent after the x, that means there's an invisible 1. So I'll put that right there, there's a 1. The last term, that is actually our highest because the x has a 3. So when we write it, we're going to start with that one. Now, you have to pay attention to what sign is in front of each term. So we're starting with the term that was at the end, and there's this minus sign in front of it. So that means we need to start with a negative. So you start with negative 4 x to the third y. You just write it down because it had the highest power of x. So that one's done. You might cross it out because you know it's done. The next highest power of x is the 7x squared, and it was positive. So you put plus 7x squared. That one's done. You could cross it out if you want. Then the next highest is the 12xy to the third, but it has a minus sign in front of it. So you put minus 12xy to the third. And the last one is that 8. It was a positive 8, so you put plus 8. So there you have it. You just wrote that polynomial in the order that we want it in. And that's descending powers of x. So you're just rearranging. You're just putting them, you're just organizing, really. Okay, example 4. Remember, you're looking at the x. So this first one doesn't have an x, so it'll actually go at the end. And then our other ones, we have a 2, a power of 2, a power of 4, and this one has a power of 1. So we want to start with the highest, which is that power of 4. That term has a minus sign in front of it. So remember to put minus or negative 9x to the fourth y. If it had a plus sign, you wouldn't put anything in front of it. You just leave it positive. Okay, that one's done. The next highest would be the 2. So, and that was positive, so plus ax to the second. There was a plus sign in front of that term. So that's why I put plus ax to the second. The next x is the one that was at the end, right here. It has a minus, so minus 2a to the third xy to the third. You want to make sure you copy it down correctly. And then the last thing is anything that doesn't have an x, or just it's your lowest power of x, because there's none there. So it's an a to the fourth. Again, it's positive, so you just put plus a to the fourth. And that's it. You just rearranged it so that it's in the order that we want it in. Okay, that is lesson 8-1. I hope you learned some about what polynomials are and just a little bit about how we work with them.